Hi, my name is Tian Window. I'm lead process engineer at Utility. I have 6 years experience in process engineering, in oil and gas, and in hydrogen refueling. So we're here at a time point for processing utilities where we can take blast furnace gas and steam from the customer, bring it into our facility, produce hydrogen, and send the hydrogen product back through the same pipe rack here as well. So part of our integration is being able to manage with the expectations for the customer on where we can take and tie in our facilities with theirs, including sending product back. So because the customer expects us to be able to take blast furnace gas from this tie-in point and send hydrogen back to the same tie-in point, we managed our own piping around our facility in order to provide hydrogen at these conditions with these tie-ins. So blast furnace gas, unlike other industrial processes, is very intermittent. So blast furnace gas is offline multiple times a year. We're able to take blast furnace gas when it's available and produce hydrogen as normal. But then whenever they're offline, whether it is planned downtime or process upset, we're able to go from an operating state to a standby state until their blast furnace gas is available again. Once blast furnace gas is available, we can go from a standby back to operating and producing hydrogen within the span of 20 minutes. Not hours or days, but in minutes. And as well, as we're here integrated with the site in Canada, we're able to winterize and seasonalize our facility to manage not only operating in the heat of the summer, but also operating in the freezing temperatures in the Canadian winter, including managing moisture content and managing potential freezes and other winterization considerations to operate in that time. As well, we're able to operate and manage fluctuations not only in the temperature, but also in the blast furnace gas composition. So our operations are not the only things that change. The blast furnace also changes in operations in a day and night cycle and in a seasonal cycle. And we can produce hydrogen whether there's fluctuations in the moisture content or the composition, and any sorts of changes in uptime or availability in a day and night on a seasonal basis. So from the time point where we bring BFG into our battery limit, the first place that it goes is into our filter separator. This simply removes any solids and other particulates that are riding with the blast furnace gas before we send it through our blower and the rest of our processes. And all that's in here is a simple cart filter like the one you see here. And this will catch any particulates and any other solids again from the gas before it gets brought into our process. So from the filter separator over there, we send blast furnace gas over to our blower. This blower will compress blast furnace gas to drive it through the rest of our process. From the blower, the blast furnace gas gets sent to the blower separator. After it's being compressed, we can separate the moisture and any water content that's riding in the blast furnace gas and condense it down to the bottom. And we can send dry blast furnace gas from the top of the separator all the way to our guard beds. So from the blower separator, we send the blast furnace gas through our 3 guard beds, where we formulated a series of 3 different absorbent materials to separate out sulfurs, halides, and also any remaining moisture in the blast furnace gas before we send it into the reactor. For other facilities, we will formulate a specialized cocktail of absorbent materials and other pre-treatment solutions in order to process the feed gas before sending it into our reactor. So this is where the magic happens. So from the guard beds, we send the blast furnace gas into our reactor here through the top. And at the same time, we take steam from the customer and feed it into our reactor from the bottom. Now, our technology in our reactor is a solid oxide membrane that only allows oxygen anions and electrons to pass, no other material. So this allows the blast furnace gas and the steam to react without ever directly interacting. So the way this works is that blast furnace gas will take an oxygen anion from the steam and produce CO2, and at the same time, it will donate electrons. On the steam side, it donates that oxygen anion over to the blast furnace gas and take the electrons that were donated to turn that steam into pure hydrogen product. Now, we manufacture our cells to be in a tubular shape, which allows us to operate this reactor basically like a shell and tube heat exchanger, where there's countercurrent flow that maximizes the reaction driving potential all the way along the reaction. So from the top, the blast furnace gas comes in and it sees the most amount of hydrogen product. But as it travels down the reactor and gets more and more consumed, it sees a higher and higher concentration of steam as steam is being fed in from the bottom. And so you have always a driving potential all the way along the reactor. Now, again, because this membrane only allows oxygen anions and electrons to pass, this allows us to produce hydrogen on the steam side without ever interacting with the blast furnace gas directly, keeping it totally separate and allowing us to produce that pure hydrogen product regardless of the composition of the blast furnace gas. Now, blast furnace gas also includes other things besides carbon monoxide or hydrogen. It has many inerts, such as nitrogen and CO2. Those gases, they enter the reactor and they exit without interacting or harming or hurting the reaction at all. They just act as kind of free riders that enter and they exit and do not require any additional separation or processing from us in order to produce hydrogen from that gas stream. So from our reactor, we send the hydrogen steam mixture out to a condenser to condense out that steam into water and send it straight into our hydrogen separator that essentially just knocks out the water and leaves you with pure hydrogen. Again, because the hydrogen and the blast furnace gas are totally separated in the reactor, we don't need anything special. We don't need a PSA bed. We don't need any sorts of membranes or anything to produce pure hydrogen. Simply a knockout drum to remove the water that's condensed from the stream, and it produces pure hydrogen. And this is totally independent of the composition of our blast furnace gas or any other feed gas. Every process is the same for the hydrogen. It's a simple knockout drum.